Hey, good morning, good afternoon, good evening, whatever time it might be where you are out there. Welcome back to the live stream. My name is Jeff Fritz, and this is C# with CSharpFritz. How you doing out there, chat room? How's it going? We're going to have our beginner-friendly day talking about all things C# today. And today, we're going to continue our focus on learning about web development, learning about ASP.NET Core. We're going to dig in, you can see in the title just down there below, we're going to dig in and talk about ASP.NET Core with SignalR and build for the live web. Those of you that are watching live, I got a surprise for you. You're going to be able to interact with me with this video right here, and more on that in just a minute. Let me take a look. Let's say hello to the folks over here in the chat room. How's it going there, chat room? Dukasoft is here. Thindall, how's it going there? Bootcom, good afternoon to you. Jason Farrell is here. Hello, hello. Spectari, good to see you. Robert Tables, he's not so little, but Bobby Tables is here. Good Monday morning to you. M. Pulowski, good morning. Robert Dino, howdy, howdy, howdy. Black Eye is here. Yes, we're going to do the thing. You're doing unusually good for a Monday. You know what? We've got about 3 to 6 inches of snow outside, and it's going to continue here where I am, just outside of Philadelphia. We're supposed to see about another 12 inches. For those of you on the metric system, that's about 30 centimeters we're supposed to see total in snow. Oh my goodness. It's a lot of snow. Is that Zeethus? Good to see you. Jedi Mega Man. Hello, hello. Nice cat emote. Love the cat emotes. Bekirp, is that good evening? Oscar Van Tol, hello. Good day to you. December 31st. No, it's not December 31st. December 31st. What? No. It's February. Yeah, it's been quick. How's it going there, Jizai? Good to see you. We jumped right through January. It's been such a quick month. You're in Sweden. 6 inches is nothing. Well, yeah. For my part of the world here, when we get more than 6 inches of snow, it's really something. We haven't had this much snow in at least 2 or 3 years. So, fortunately, the kids don't have school at school. They're at home doing the whole virtual learning experience. So, Spectari rarely has snow. In South Africa, well, yeah, that's something that I wish I could appreciate. My goodness, I accidentally started the stream on the wrong channel. You're right, I did. I forgot to reset the stream, so we were broadcasting over here on Visual Studio. So, you heard it snowed in Florida this winter. Not only that, it snowed in Malibu, California, about a week and a half ago. So that was a thing. That was totally a thing. All right, let me get in. Let's talk a little bit about SignalR today, and let's review where we are, where you can find more information about this series, about everything that we're doing here, learning about ASP.NET Core in our beginner-friendly discussion, our series here, and I want to give you an opportunity to interact with the video here. All right, so let me head over to. We'll start off on the GitHub. We'll take a look at the hub of all things Git over there, and we'll get some music playing in the background from our friend Harris Heller and his Stream Beats. This is called the Synthwave playlist, and this first song is called VR Birds. It's a bunch of groovy music that's royalty free that you can use anywhere you'd like on YouTube or Twitch. Check it out. You can find it on Apple Music, Spotify, all those places. It's called Stream Beats from Harris Heller. Thank you so much, Harris. We appreciate you letting us listen to your music while we write some code, talk, and have a good time today learning. Very much appreciate. So this is the repository for the series that we're doing here, C# with CSharpFritz. You can find it on GitHub, github.com/CSharpFritz. That's me. /C# with CSharpFritz. Link is in the chat room there, and if you're watching on the YouTube video, it's linked just below in the description. And if you're over on Learn TV, I'm sorry, I don't have a way to post a link there for you. You'll see the links coming up later on the recording. So let's talk about we've gone through a lot here with ASP.NET Core. We've gone through now 5 episodes. This is our 6th episode in the series. We've got a few more topics that we're going to cover before we wrap this up at the end of the month, and we transition into talking about Blazor. Blazor is our next topic. We're going to be talking about starting in March. Blazor is a user interface framework that you can build for the web. You can also build for mobile applications with it as well. So today we're doing SignalR. Coming up in the weeks ahead, we're going to talk about security. We're going to talk about microservices, Docker, and Kubernetes. We're going to show how to deploy to Azure. We'll talk about background hosted services and cross-origin resource sharing, or CORS. It's a little bit misunderstood, but very powerful technology you can use to manage interactions with your website. Excuse me. So let me make sure the music's at appropriate volume as it changes. I think we're okay right about there. So those are the topics ahead, and really looking forward to digging into those more. All the source code, all the samples that you've seen on this series, they're available in this repository out on GitHub. I'll add some more text into the READMEs, so there's more there for folks to link off to and learn from. Hey there, Chris Jones. Good to see you. So, SignalR is folks hear that framework name, and they have it's kind of tricky. Folks don't know what it is. It doesn't come right out and scream, "Oh, I'm sockets. I'm the live web. I'm a web framework." So we need to dig in and talk about what exactly SignalR is as we get started here. Oh, there's a question here from Shy Sharp. Let me allow that. Asking, how's my dog? Doing quite well. Yesterday, woke up in the morning and my dog was quite sick, and had to run her to the vet, and it kept me from streaming on Sunday morning, one of my normal times. So she's doing quite well. Hey Charles, good to see you. Welcome Santhology, nice to see you. Now, a bit of what we do here on Twitch on these live videos is you watch me and I react to your chat. What if I gave you an opportunity to turn this around, and I'm going to demo SignalR to you by letting you interact and put stuff on this video? Here's what I've got for you. I put together a little website using SignalR. It's out on Azure that you can go to, and it's got 9 buttons. And when you click these buttons, they make, if my demo isn't refreshed here, they make those same emotes appear on my screen. All right, so if you're watching this live, I'm going to copy and paste this URL into the browser, into the chat room. Go ahead to that location, and you can click these buttons, and through the power of the internet, it will send those emotes, and they'll appear here randomly on screen, bubbling up and disappearing. What you're using to make these images appear, this is SignalR. Look at that! Look at that! All right! This is, you've done something on your machine, and it's pushed a message through a server on Azure onto my machine that's listening for response. And when it receives that message, it's grabbing the appropriate image and putting it randomly here on screen and bubbling it up. Is there a rate limit? No, there's no rate limit. We're not going to have more than 100, 150 people clicking through here, so we're going to be all right. So, not bad. That's something pretty cool. And this is a technology that you see when you go around and you participate in various websites, whether it's Twitch, whether it's YouTube watching a live video, it's It's over on Learn TV, and you see a chat room appear, and there's messages that are appearing regularly. As folks key in chat messages, those appear automatically on your screen as they press enter. How do they do that? They're sending, right, when you key in that message, you're not sending it directly to my machine, you're sending it to a server that's being managed by one of those websites, and it turns around and sends that message down, paints the screen for all those clients that are attached. Maybe it's your mobile phone, maybe it's a web browser like this. So how do we do that? How do we do this interaction to make this work? There's a number of different technologies that folks have used, including polling. Polling, when you think about it, is actually the clumsiest and the oldest way to do this. You would set up a script that runs in your browser that every few seconds would go and request from the server, hey, do you have information for me to work on? And depending on whether or not it got data, act on something inside the browser and go perform, make that happen on screen, do something with that. Now, there were other technologies that have been built and extended since then. There were tricks that were being used with how you created your connection to the server, things like what was called forever frame, where there was a hidden iframe that would just hang there and not close its connection, but receive messages, and as it received messages, hand them off to the browser to do something with, and after an appropriate timeout period, eventually close the connection and reestablish a connection and continue listening. Similarly, there's a technique called long polling that would do very similar interaction. Make a request to the server, wait, don't close the connection, and interact with it as data is being delivered into the browser, but never close the connection until a timeout period hit. Now, if we look at, there's a page here called Introduction to SignalR, and it has a nice little diagram here that I wanted to reference. This is referencing the documentation for the original version of SignalR that came with ASP.NET, not ASP.NET Core, but the older version that runs only on .NET Framework. You ended up with these two models, where you had on your client, you had some sort of a proxy that would connect over to a server and receive data. But in SignalR, we turn around the model. On the server, we have a technology, an object called a hub. Now, our SignalR hub is what's going to decide how and when to send data to clients. We can connect to that hub using a bunch of different server technology on the server, and we make a connection to it using a client that's designed to run on our client application. It could be HTML and JavaScript, it could be a .NET app, it could be a Java app, many different technologies that you can use to connect to the SignalR hub running on the server. Then the hub can relay and push those messages into the client. So the technologies that we use now are WebSockets. So now with HTML5, we work with SignalR, and SignalR provides an abstraction. It provides a shim on top of WebSockets. But if for some reason WebSockets are blocked, if the browser, if the client is not capable of working with WebSockets, SignalR has smarts built into its protocol where it will negotiate a different connection strategy so that it always gets that connection. And SignalR connections are two-way. Not only can we push from server to client, but the client can also make requests to the server. Now, this is the older technology that you see here, and you see some documentation that looks like jQuery. And the older SignalR depended heavily on jQuery. But now with HTML5, with some of the modern innovations in JavaScript, you don't need to use jQuery to work with the browser. So this is a little bit about how it works, and you still see some folks tapping the buttons there. Go for it. That's fine. I'm going to let that ride today. So So let's get in and talk about a little bit further about how this demo, these things work that you see here. I'm going to pause for a second. Let me answer a couple questions coming in from the chat room. I'm not going to put this one up, but Juan, play to the play. Check out the title. We're learning about SignalR today. Is Windows my daily operating system? Yes. I do also use Linux on a laptop, and I wrote some of these demos that we're going to see today, all on Linux, and they work on both Linux and Windows. Greetings to you in the Ukraine, Apricot. Yeah, Apricot, good to see you. Yes, SignalR started as a hobby project for now the ASP.NET Architect. Really, really neat technology. Okay, so let me show you how this works. Behind the scenes, here's my application. We're going to take a look at this demo in a second. We have a startup class in ASP.NET Core. We always have this startup class. And this time, in here, inside of our configure services, we saw how to work with Razor pages way earlier in this series. And now I have add SignalR. And this adds a SignalR series of logic into the ASP.NET services so that ASP.NET Core knows how to work with hubs, knows how to manage those connections, and it knows how to work with WebSockets appropriately. So, looking a little bit further down inside of our configure method, where we configure the pipeline for interacting with the connections, I have two hubs defined. I have one called Shape Hub, and I have one called Emote Hub. These are two types, so I'm defining, hey, this thing, this SignalR service hub is going to listen on this address on this server. So in this way, I know exactly where to interact with, in this case, the emote hub, the emotes that you see appearing here on screen. Now, that's where it lives. Let's talk about and dig into what it actually is. So I'm just going to go to definition on that emote hub. Is my, yeah, Karnak's running, right? Yeah, there it is. I hit F12 to do a go-to definition there. I see a couple questions there in the chat room. I will come to those in just a second. Let me pin these. Wrong channel. This channel. There we go. Okay. So inside of here, where I define this emote hub, I have a method called onConnectedAsync, and we do some things there for managing what happens when somebody connects to this. I'll come back to this part in a second, but this gets a little bit interesting with being able to select and work with different types of clients that connect. But this is that server-side method. This is what gets called when you press one of those buttons inside the browser. So I call the send emote method on the server. I'm logging a little bit of information, just writing out to the console, hey, I heard this button number was pressed. And I go find my OBS group. I have a group of clients that are connected that are identified as OBS. And I send a method call to it using this send async method. And the method that I'm going to call is called fly emote. And I pass in the ID of which emote that I'm going to paint on screen. Okay. This kind of makes sense. I have a dynamic method that I'm calling, right? I'm specifying the name of the method to call and the arguments after it. Let me pause for a second and answer some questions here in the chat room. How's it going there? Coding After Work is here. Hello, hello. They had a great event last week talking about front-end development for folks in the .NET space. And I'm actually going to be joining them on Thursday afternoon over on my channel. Starlin asks, is this .NET 5? Yes, it is. Yep. We are all .NET 5 on this series going forward, and you'll see more about .NET 5 and Blazor in March. Santhology asks, what are the prerequisites for this stream? No prerequisites. .NET 5 you can download and install. There's instructions for how to install at the GitHub repository. I shared that link a little bit earlier. I'll share it again here. There's the link. And if you want to see the emote demo that we're looking at right now, you can go to that second URL in chat. How's it going, Screech Rat? Good to see you. So this is how the server sends a message to the clients. So I have a little page here called OBS. And this page just has a little bit of CSS to do the animation for these images. When you click those buttons, I'm applying this little bit of CSS animation, right? Big deal. Nothing terribly complicated here. We've got some keyframes that move from below the bottom of the screen, there you go, to 500 pixels in the screen, and they slowly fade out as they move up the screen. That's pretty... nothing innovative about that CSS. Nothing really there that we're interested in for the purposes of talking about SignalR. Here's where SignalR as a client comes in. This is embedded inside the video. OBS, the tool I'm using to broadcast here, lets you embed a browser. So this page is running inside the video here, okay? It's an invisible overlay. So I have a script here. This is the SignalR library that's made available. It's a client library that's made available for you on NPM. And I have a package JSON file here, and you can see it's sitting at Microsoft SignalR. So I can do a pretty standard npm I command and install that library, copy it out of the node modules that are delivered, and I have it sitting right up in here. I just copy the file right there, SignalR min.js, so I have it available to me. So I reference it here, so it's on the page, and I can use its capabilities to connect to a service. And I have to tell it, I have to write some script to connect out to my web server and interact. So here, I create a new SignalR Hub Connection Builder. This is a little utility class that will define all the things. It has all the things for me to make connection information, meta information configured to get connected out to my server. So with URL, go connect to the URL /hub/emote, right? That's where we saw this is being defined. And I'm passing in, see this query, $group equals OBS? Now let me go back to that emote hub and show you what on connected. So I'm going to check out and look for that group query, right? After the item after the question mark. And if it's null, if it's not null, then I'm going to add to group. I'm going to go take this connection, and I'm going to also add this connection to listen on that group. So I now have a group called OBS, and my OBS instance here, the browser that's embedded inside this video, is connected to the OBS group on my hub here. So now it will receive messages that are being sent just to OBS. And here's that fly emote method that is being called when send emote is executed. So reach into the OBS group, this browser, and execute the fly emote method and pass in some integer. Look at this. We got the exploding brain. Look at the exploding brain. Yeah, that's right. So we'll pass in that emote ID. So I create a new image, right? I'm receiving, there's the argument being received. I create a new image. I set the source equal to image button ID.png. So there they all are. Set a class name to float, right? That's what I'm putting these keyframes on up here. Set a starting position, randomly set its position here going across the screen, math random times 100%, so it's randomly across the screen, and just stick it on the screen. Just put it right at the bottom of our HTML. Pretty garden variety stuff. Important, I always forget this. If you see me do a demo live coding SignalR, you will always see me forget line 63. Connection start. Connection start means take all of this information. Now that we've configured how to respond to the commands that are coming in from SignalR, take this and go connect to /hub/emote and start listening. Okay. I added another little method down here at the bottom, just on every 2 seconds. If we have images that have reached the top of, right, if they've moved to the top of their animation, remove them. We don't need to have thousands of image tags sitting here inside my browser. Remove them, clean them up. They're hidden. We don't need to see them anymore. This is just regular JavaScript here. Nothing particularly SignalR-ish. Is that a word? Is that a word? That about this code. So now let me go to the other side, and where we actually have those buttons that you're clicking to send messages. So I've got 9 buttons, and they're just set up and pointing to the various images that are out there. Once again, I make a connection to my SignalR hub. I'm connecting to /hub/emote. This isn't going to receive those messages. So when you open your browser, you aren't receiving the messages with the emotes to paint on the screen. I created a constant. I go select all the buttons that I've painted on the screen. For each one of those buttons, let's connect an on-click handler. When it clicks, now here's our next piece of SignalR that we're going to learn. Take that connection and invoke. So now invoke a method that's on the server. And here's where it calls send emote, and it passes through the ID, the data ID from the button. So send emote and the arguments. Tell it that we're pressing button 1, button 2, button 9, whatever, and start. So now it's wired up, so you click those buttons, it sends a message to my server. My server, my SignalR hub, has this method executed, and it notifies all the clients in the OBS group to fly the emote with the ID that you submitted. And to finish that cycle, fly emote creates the image, sets the source appropriately and all this, appends it to the screen, and the animation happens. No jQuery, all vanilla JavaScript, right? So pretty clean, pretty simple interactions in order for you to write some code that runs in the browser and paint things on the screen. And I thought this was a pretty fun way to allow folks to interact and put some stuff on the screen to play and show that now we're receiving data coming the other way. All right, cool. Let me pause for a second. Dukasoft has a question here. Let me cue this up. Are there any plans to make this less JavaScript and more C#? So there are several different clients that you can use to connect to a SignalR server. I'm showing the JavaScript one here because it runs natively in the browser. You can get clients for .NET. It's a .NET standard package. So if we head over to NuGet, and it's I believe it's SignalR core.client, I believe is no, it's ASP.NET core.signalr.client. There it is. So this client can be used with any .NET Standard 2.0 compatible version of .NET. And it has the very same syntax that we just saw. So we can easily connect a Xamarin application, a Windows Forms application, console application, to a SignalR server, listen and interact and take appropriate steps. And it's both ways. The syntax is very similar to what we saw with JavaScript. So not only can I receive messages from the server, I can send messages as well. Which comes around to a question that we had last week. Well, why use OpenAPI or gRPC instead of SignalR? So SignalR is very scalable. We've had, what, 50, 100 people tapping on those buttons on the demo here to make emotes appear on the screen. But there comes a point where you're going to press up against the memory limitations of the server. The processing is not going to be able to handle. This was a basic web server that I stood up on Azure App Service. It's not going to be able to handle more than a couple hundred folks connecting. So you can scale up your server. Some folks want to scale horizontally. So scale up meaning, let me get more processors, bigger processors, faster processors, more memory. Or when you scale horizontally, let me add multiple web servers. Have 4, 5, 6 web servers all working to present this website. When that happens, you need to introduce additional technologies in order to have all of those connections talk to each other across the servers, so that when you click a button on this web browser that's connected to, say, server 1, my web browser that's connected to server 6 needs to be able to hear that message from server 1. So we create and we use a technology called a backplane that sends messages back and forth between the servers in the back office behind your requests on the front going out to the browsers. That backplane passes messages back and forth. Look at all the emotes. That's awesome. And will notify clients on those servers appropriately if there's something that they need to interact with. And we'll see more about the backplanes in a minute here. So, 2 ways that you can scale this. So, now, this was a pretty simple sample. You're pushing a button, you're displaying some stuff here. We're not doing anything that compares too much to a business process, right? What if we want to do a little bit more here, right? And I'm not even going to do anything more businessy. But let me show you just how fast the connection speed is going back and forth to the server. So the next demo that I want to show you is one of the first demos that were presented for how to interact, how to work with SignalR. And this was something called the Move Shape demo. And this is one of those demos that when folks see it for the first time, their minds kind of explode. They're like, what was that? Let me comment out these 2 parts, and we can take a look at this. I'm going to run this not on IIS Express. I'm going to run it on Kestrel, the Kestrel web server. And actually what I should do, I don't want to run it like that. No, cancel that. I see a couple questions here. Let me queue those up while I yeah, there we go. I'm going to .NET Watch run. So I can have this running in the browser and we can start and stop this. There we go. So we're gonna look at this demo, but we have a question first from Jeremy. Why invoke and not send? In this case, they'll both work. One returns, I think, invoke returns a status code from the server. Send is like a fire and forget, if I remember correctly. They both work the same for the purposes of this. To each their own. It would have been fine. There's a question here from Vidal asking, does this work with ReactJS? Yes. All of the interactions, all of the JavaScript that we've written here, this is just using the SignalR library to create, here we go, SignalR Hub Connection Builder. Once that connection is created and you specify the interactions here, what you do after that is up to you. So you could certainly interact with your React components, your React libraries, to pass information around and have a good time with that. So yeah, you can certainly use it with React. You've used a lot of SignalR in the past, and about 1,200 connections to the server, and it started to blow off. What is the performance of SignalR in real conditions? So this is what we were just talking about. You're going to hit a maximum size on a server. Yeah, about 1,000 connections sounds about right, depending on the size of your server. Couple processors, couple gigs of RAM. That sounds about right. So this is when you want to start looking into a backplane and have connections and communications on the back office between servers. I'll talk about that in just a little bit. But this is where you want to start scaling horizontally and bringing in more servers. Timmy says, I've seen someone build a small multiplayer mod for a game using SignalR. Absolutely. Real easy to do because you have so many great clients for SignalR that you can use. Java, C++, .NET, you could drop in and update and interact with servers using SignalR. Absolutely. No problem there. Or is that Oralaz 666? We'll get to that in just a minute. Not a problem. I completely understand the question there. That's right, Simonot. I think I've seen that demo as well. A multiplayer Microsoft Paint clone using SignalR, so you can have a community collaborate to paint. So this demo is actually a little bit towards what you're describing there. I have a square, a shape that I'm painting on the screen that's 100 by 100. I've made its background color blue. It's positioned absolutely. I've popped up the z-index so it's just above things, so we can drag it around. And I've set up a couple of event listeners here so that I can drag it around the screen and move. And that's fine and dandy. Whoop-de-doo, you can drag that around. But what starts to show the performance of SignalR, great, you pressed a button in that other demo, and what's the lag? How long does it take for things to appear on this screen? Let's shrink that. Open another browser here. And I have fancy zones on, so I'm going to have to drag to resize this. I'm not going to be able to just snap. So it moves very responsively. Every time I move, when the on-mouse move event happens inside the browser, it's sending a message to the server and it's notifying all of the attached clients that the shape has been moved and to move it appropriately. And it works in both directions. All right? So there's very little perceived lag between these. And it doesn't have to be just two. Right? I'll add another one here. And it's not just inside of Firefox. I'll open up our friends who make Microsoft Edge, and we'll drag this over here. We'll bring that over as well. And now you see it works in Edge, it works in Chrome, works on Safari, all the major browsers. It knows how to negotiate and work appropriately inside those various browsers. Okay, so you get really good performance low to no latency, sending messages back and forth. Yeah, go ahead, click those buttons. It appears there's a little bit of a delay because there's a few seconds delay in Twitch, in Microsoft Learn TV presenting content to you. But I hope what you're seeing here in how I'm dragging this and they all update instantaneously, that the relay, the latency between your SignalR requests is near zero. It's single-digit milliseconds. To the human eye, it's pretty imperceptible. All right, so that's really awesome. Yeah, this is great for scaling WebSockets. It almost feels like magic. It almost does. How's it going, Curious Drive? So this is fine to show some of that latency, but we still haven't really passed data around in a way that's interesting. Something that's going to show some information that we want to work with here. Nix asks, can you try something else other than localhost? You see these things? This is coming off of Azure. See these? Check that URL. No, I'm not counting how many times the emotes buttons have been pressed. Check that URL. I just pasted into chat. These are coming off of Azure. So this is being updated and showing you live coming in from out there. Yeah, go ahead. Tap around there. So I should count how many times these things are out there. So it's quite fast, yes. And you're benefiting from some of those performance investments in ASP.NET Core, in C#, so that we're not passing around so much in memory. It's passing around pointers to memory. It's not reallocating data. The call was coming from inside the cloud. Nice blue cloud. That's right, Robert Tables. So, right, this is a cool, fun, interactive technology that you can use. But when you think about not just chat that you're seeing in the interactive video here on Twitch and Learn TV over on YouTube, but think about how many times you watch scoreboards over on your favorite sports website, and it's updating automatically as things happen live in the match, right? You're getting status updates and, right, something appears, goal scored by, right? Touchdown scored by, home run hit by, right? These things happen and it shows automatically there. That's typically some sort of WebSocket technology, and SignalR provides that shim on top so that you don't have to worry about opening and closing and interacting with the sockets. Additionally, when new technologies evolve, new compression technologies, new protocol technologies that we want to use, if you're working with SignalR, because you have that abstraction on top of it, you don't have to worry. You don't have to change a thing in your code, because when you install the next version of SignalR, if there's something faster, something that performs better, you'll be able to use that maybe by opting in when it first rolls out, adding a statement into your startup so that it says, oh, use this technology. And eventually it may turn into a default, and now all of your connections use that new, faster technology to connect to different clients, different things, and behave appropriately. Think about interacting with things like IoT devices, right? You have some sort of a sensor somewhere that is connected as a SignalR client to a server running in the cloud, and it's able to send messages out to that server easily and receive messages on that same socket connection without a problem. Now, what happens if the server goes away? What happens if my network goes away here and I need to somehow tell folks, hey, network's gone, you should refresh the browser. Or even better, I want to automatically reconnect because you lost your connection. So there's a couple event handlers that you can use to update to update your interface to let folks know, hey, I lost my connection. Either refresh the browser, or we can even try reconnecting. So let's add a little error note into the demo here. Let's add a little block in case for some reason we become disconnected. And I'll shut off my server in a second, and you'll see exactly what that looks like. So I'm going to add a little bit of CSS into this demo, defining what an error looks like. Here we go. So I'll put a red border around it, put a little bit of padding and margin, red font, nice bold font weight, and have it hidden for now. And I'll add right here. Why you do this? Really? You're gonna... I'm using the new experimental Razor editor here. So div ID equals error. All right. And what I can do down here is I can add some methods. I'm going to add them right before these two, where I'm going to show the connections. I'm going to add some methods to handle the on reconnecting, on reconnected, and on close events that happen with our connection. So while we're trying to reconnect, I'm going to log out to the console, reconnecting, and I'll put into the error block, connection lost, attempting to reconnect, and I'll set its display type to block so it appears on screen. When we are reconnected, clear out the error block and hide it. Finally, when our connection is closed, output, well, connection's lost, refresh to attempt reconnection, and make that appear. So now let me go back over to my browsers. Let's put those back up on the screen. And we'll even grab that one Microsoft Edge one and make that appear as well. So let's refresh these now that I've updated. Right, did I save that? I didn't save it. Rats, didn't save it. I'm gonna put that up, and this, and that, and this one over here. And I'll refresh these so they all have the new content. And my move shape still moves the shapes, but I'm going to go and kill my server now. So I just killed the server. And I should be getting an error message here that, oh, it was disconnected. Oh, look at this. All right. It's not a function. Oh, no. I have an error in my code. Rats. Let's go take a look. Well, that shouldn't be that way. It should be like that. I can't restart. I need to actually restart the server. One second. Look at that. I got carried away trying to make this work. Close that one. Refresh. Good. Bring up the others. Refresh this one, this one. There we go. Now I'll kill the server, and it knows that the connection was lost, and refresh to attempt reconnection. But I don't want somebody to have to click a button to have to refresh. It'd be really cool if you knew that, hey, the server's down, attempt to reconnect. So in SignalR Core, SignalR on ASP.NET Core, there's a with auto reconnect method that you can call that will have your client attempt to reconnect automatically and begin interacting with the server again. So after this with URL, I can say, find my notes, make sure I'm doing this right, because if I get the capitalization wrong, I'm going to feel shame. I thought it was a lower, with automatic reconnect, too many N's, and it will automatically reconnect after a couple of back off periods. So I'm going to bring these up and force the refresh so that we get the new data here. There we go. Move shape works. And I'm going to kill my server. Connection lost. It's attempting to reconnect. And if the server comes back online, I'm going to .NET Watch run again. one of these is going to get a browser opening. And notice the error block went away. I didn't refresh the browser and they're all connected again. So very handy to be able to drive those clients so that they're always connected, right? Nobody wants to have to click that refresh button. And better yet, nobody wants to be told that they've been disconnected. Try reconnecting and try a couple times. And, you know, once you get reconnected, great. But if something happens after a Herculean amount of time, we tried and tried and tried, you know what? You're in the middle of a cave with your phone and I can't get to my web server. I need to put a notification on the screen that says, sorry, no connection. You can do that, right? So if I cancel this, if I shut down my server, I canceled it behind the scenes, connection lost, attempting to reconnect, and it's making its reconnect attempts, and eventually it's going to stop and say, I wasn't able to connect, and it's going to show me that errored out message here. Look at all those messages. Look at all those buttons. Somebody's written some script to try and get the buttons hitting multiple times. So give it a second. A few seconds here, and it will eventually say, unable to reconnect. Do I see a couple more questions there in chat? Let me, while this is coming around here, let me take a look here. The question here is SignalR the right framework for WebSockets between .NET applications? I know nothing about SignalR. So WebSockets, you can absolutely use between .NET applications. Nothing wrong with using those at all. SignalR, though, gives you the ability to scale, be able to choose appropriately those different connections that you want. It allows you to set up there you go. See, it says connection lost, attempting to reconnect. And up at the top left one, connection lost, refresh to attempt reconnection. There you go. Right, they've all updated their messages. So, SignalR gives you this abstraction so that regardless of whatever client, it will connect and interact appropriately. If you use WebSockets, you're going to end up needing to create TCP sockets and manage the state of that socket connection. You're going to have to listen and receive messages and turn them back into method calls or data to process. Very, very fast to work directly on the socket, without question. But if you're just looking for something so that you can call methods, right, make that remote procedure call from the server to the client or from the client to the server, SignalR wraps that up, provides that abstraction that makes it so much easier to interact with. So, now, Robert Tables, my friend, thank you so much. Asking the leading question here, getting me into the next topic. Field Marshal, I'm going to pin your question, and I can answer that with the emotes we're looking at. But Robert Tables asks, is that specified by a number of attempts or a duration of time? So the with automatic reconnect that we added in here, there are a default set of backoffs. It's not going to show me it. There's a default set of backoffs that it uses there. Let me look at my notes over here. By default, it will attempt to reconnect immediately, 2 seconds later, 10 seconds later, and then 30 seconds after that. So it tries to reconnect, waits 2 seconds, tries again, waits 10 seconds, tries, and then 30 seconds. But maybe, and after that final 30 seconds, so a total of 42 seconds, it finally gives up by default. But maybe your application, you want it to try a little bit more. You want it to try at a different interval. You know the operating characteristics of your application best. These are some reasonable defaults that the .NET team programmed for us. But you can provide an array of milliseconds that it will attempt to reconnect. So I can say, try again immediately, try again in 1 second, 1.5 seconds after that, 2 seconds after that, etc., etc. However many times you want it to reconnect, you can just build out those number of reconnects. And now when I go back over to my browsers and I restart the service, I'm just going to .NET run. There we go. So I'll refresh these. And the shape moving works just fine across. But when I shut down my server, it's going to attempt to reconnect, and it's going to fail much, much quicker because I only have it refreshing, trying to reconnect every second or so. But if I restart the web server real quick here, it'll get reconnected, and boom, that goes away when everything is up and running. So I see a couple more questions here. Let me queue these up. I'm going to finish the second half of Robert Table's question here. So you could control the back pressure, the pressure coming back into the server, so that while the server is down, it's not being hammered with everybody trying to reconnect all at once. By creating that timeout space, you're right. We're preventing a retry cascade into, melting a server down. We're not able to reconnect right now. Give me 5 seconds for the server to start back up, and then try again. 10 seconds after that. Give it 10 more seconds to make sure, and this way hopefully your connections are spread out so that you don't end up with a cascading failure. You're spot on there. Field Marshal, let me come to your question after 2 more here. So Skycom asks, where can I find the demo code? All the demo code is inside our GitHub repository. Let me provide a link to that. There it is. You'll see a branch session 0206. The initial version of the demo code is there. If you're watching the recording, the demo code's been updated with everything we've worked on here on stream. There's some notes there as well that I've added. But if you're watching live, you can go there and you'll find the branch and you'll find the folder where I've been working on this, and all the demo code is there for you to grab and tinker with, and you can run on your local machine. Thank you for the interest, Skycom. I hope you check it out and you find it interesting. Bert's Day asks, can I implement SignalR with Azure Functions? Yes, you can. There is a service that runs on Azure called Azure SignalR Service. Man, these guys know how to name products. No. These folks that name products, all right, made it quite simple, quite clear exactly what it does. The Azure SignalR service, quite simply, will host the server interactions. It's one of those backplanes that we were talking about that you can connect your SignalR application to, and it will relay messages between them. There are bindings for Azure Functions that you can use, and you point them at the Azure SignalR service. You'll stand up a SignalR service. You set up your function so that it has a binding to a hub, to a topic. I believe it's to the topic on the SignalR service, and you can respond and behave appropriately based on that. So, very cool stuff that you can do there with Azure Functions. Lead Geek asks, how about SignalR versus something like GRPC? So GRPC uses HTTP2. It uses standard HTTP calls to send and traffic data back and forth to the browser. Now, wow, lots of folks clicking those buttons right now. Very cool. So GRPC is multiplex. The message is going back and forth, and you can stream data. You can stream data with SignalR as well, if that's something you want to do. Oh, look, somebody really wants to try and cause this thing to fall over. Now, that's just the animations of my browser, because you've sent through so many icons, so many images. Now, but what SignalR has that GRPC does not, SignalR is using sockets. So you end up with that persistent connection where GRPC will eventually GRPC will eventually disconnect. So you can have a SignalR connection. The connection here that you're seeing for these emotes has been open the whole time. So what? I'm in an hour and 5 minutes into here, and this is chugging along just fine. So, okay, we can do these things, and when we talk about deploying, we get into the question Field Marshal has here. How do you host your SignalR service at the cheapest cost possible? So, right, what's involved here? So, this application that I'm running, that's hosting these buttons, and we saw somebody trying to overload this, and it handled it just fine. But if you want to run this out on, like I am, on Azure, I'm going to make sure that I have my all of my Azure data obscured here. I deployed this to Azure App Service, and this is running on the free tier. I'm going to make sure, where is it? AZ Mask is on, good. Nope. Nope. They updated the UI and they broke AZ Mask. Nice. Way to go. Nope. Not going to show that. I will show, so I deployed this to, yeah, sorry. I am not going to show when they make everything so visible on screen. Like, sorry. So here, this is Fritz SignalR, and I'm running on the free tier. This is 1 gig of memory. 1 gig of disk storage. And, right, it's running just fine for, what, we have 100 people. We had somebody run a couple scripts. That's fine. Nothing fell over, nothing broke. It's still sending through the emotes just fine on screen. And, right, I mean, for 150 people connecting, that's not bad at all. So if I need to scale out to thousands of people connecting in and working with this, that's when we use the Azure SignalR service. And I'm not going to show that today, but it's very easy to set up and run. It's a couple of extra statements you drop into your server, and it knows how to connect and work with this as a backplane. And the pricing's actually, it's not too bad. When you're talking about having thousands of connections coming through, for each unit, you can think of unit as a server. You can send 1 million messages for free, but 1,000 concurrent connections to it at a price of $1.61 a day. That's not bad, right? 30 days, you're talking about, what, 40 bucks, 45 bucks American? And you can stand up to 100 of those. So you can have 100,000 people connected using Azure SignalR service and notify all of them at once that something occurred. Send all of those things through. So, cool, right? That's one thing. Now, maybe you're not on Azure and you want to use something else. There is a Redis backplane that you can install as well. You can stand up a Redis service, and there are instructions in the documentation for connecting to and working with Redis as the backplane that will exchange messages between your servers. That's right, links do get censored, so add a space in there, and they'll appear on screen. Interesting. They wiped all the VIPs. Yeah, they wiped all the VIPs. I'm not sure who did that. What? That's interesting. Actually, it looks like they... Over here... Yeah, all the... Oh no, yeah, Blazer Mr. Magoo has a VIP. I wonder why they... No matter. Really? Try that again, Jason. You should have VIP now. There's a lot of folks that broadcast on this channel, so... yeah, look at all the messages coming through. So, it works fine. So, right, this is free service and it's working just fine. So if you need to scale up, you need to add more capacity to this. Somebody was saying they got through to about 1,200 connections, right? And they were still fine. For most internal applications, you're going to be just fine at that scale. Right, and I'm very cheap here and going and scaling and adding pressure. It's able to handle it. So, is that Neo's Sus or is it Neo's US 2? Neo's Us 2? Can I host SignalR on a virtual private server or is it just for cloud? I'm hosting and running it here on my local machine for this demo, right? So when you see me over on my channel, on the CSharpFritz channel, and I have the various interactions that appear on screen, whether it's you play a sound effect, you you ask for hat identification over there, those all happen with SignalR being hosted and delivered out of a Docker container. So you can run it pretty much anywhere. Anywhere that an ASP.NET Core web server would run, you can host a SignalR endpoint. Let me see here. Is it Bakir P asks, will it work as a mobile app with notifications? It's not quite the same. The mobile devices have a different mechanism that they deliver notifications, that they listen for notifications and raise those notifications on the device. That technology goes through those vendors, and you have to subscribe and interact with their services independently and separately. But inside of your mobile application, being able to send some sort of a pop-up message that appears inside of the web browser, yes, you could do that. Some sort of a message that pops up inside of your Xamarin application, you could do that. Hey, Rambling Geek, yeah, you could even use you can connect to if your mobile app is a progressive web application, you can send information to that, but it's not going to raise it to a notification on the device. It's only going to be while it's open. Like I said, you have to use those vendor-specific notification mechanisms in order to send a message that will actually trigger on the device as you have a new tweet, you have a new email, you have a new TikTok you need to pay attention to. So, slightly different mechanism. And Blazer Mr. Magoo's right. For dev testing, small group testing, the free tier on Azure is great. If you have a small application, something like we're doing here, you've seen. The server is not falling over. It's running just fine. I want to look at the monitoring on this without going to that front page, because that front page has all my data on it. Let me pull this over here. Maybe I can just scroll down a little. Let's see if that works. Yeah, there we go. So, right, I've no errors, no 500 errors. I haven't pushed a lot of data out. A couple meg here a few minutes ago, but I'm not putting pressure on this at all. Response time got really slow there for a little bit. Gee, I wonder, right? It was while somebody was hammering the service, but right when I look at when those giant data points came through, it wasn't hurting the server. So we're still in fine shape running out there. Okay. So you're guessing the service worker would have to be specific to SignalR if you built a progressive web app based off of it. It would need to listen for it. You would need to integrate something to listen for it. I'm not sure that works because you'd have to have the SignalR library working with the service worker. You might be able to do it. I haven't tried it. There might be something there. Now you have me thinking about an application that I've been building and that I want to turn into a progressive web app. So, okay, we've seen this. Let me take another step now. Let's work with some more of that metadata that's going on behind the scenes, particularly around the connection information. So, when somebody connects to the server, connects to the SignalR hub, we have an event that's raised on connected. And we can override that so we can provide some additional business logic. In this case, I'm just going to grab a count of the connections, stash it in a private static variable. When you disconnect, I'm going to decrement the count, and I'm going to send a message to all connected clients and say, I want you to call a method called count and pass through that integer. Okay? Now, there's other qualifications besides all here that I can use if I want to send to different groups of clients. I can say all except and pass in a connection ID for whoever it is that we don't want to send notification to. I can send a message back to the client that called this method, that called the onConnected async. I can target a group of clients and pass in specific connection IDs. You already saw I used group. I can pass to a group except for some connections in that group. I can say, well, notify all the others, everybody except for who triggered this method. And when you're logged in, I can even target user IDs and effectively have a secured SignalR communication. Is that call to count, add, and decrement thread safe? No, it's not. It's not. I could make it thread safe. I could do interlocked.increment and interlocked.decrement. I could do that, right? I'm trying to make this as simple as possible without getting into all the threading concerns. You're right, it's not. But for the purposes of showing a demo with 4 browsers, it's good enough. So with this in now, and each time that I get connected, increment the number of connected clients, and decrement when we disconnect, I'm going to go back over to my move shape demo, and I'm going to I'll put these both in. And I'm going to add on, I'm going to leave the timer demo out for now. There we go. Come on. You know that works. I'll restart the server. Yes, I know. And now, as I bring these services up, there you go. Look, it says I've already got the connection lost attempting to reconnect, right? And they're reconnected. I need to actually refresh them so they get the new source code. But check it out. 4 connections, because this one already is reconnected, but it doesn't have the display. So it's counting the number of connections and putting that on screen. So if I copy this, let's open a new tab, 5, 6, and they're all updating immediately, right? Still doing the move shape, that still works. And right, I'm maintaining information about the connections. So when you're building your cool application, you can send this information back to some sort of administrative console. And if you're watching on Twitch and you see the user IDs here on the chat room over here, it's the same type thing. Here's the folks that are connected, right? That onConnected event has fired. Similarly, they're not using the same technology, but I'm drawing a comparison here. The onConnected event is fired, and it's showing here's the folks that are connected. When one of those folks closes their browser, it'll pop their name out of the list, and you won't see them there anymore. So the emote website I'll put back into chat there so you can tinker with that. So that's fine, right? I'm passing around information about the folks that are connected, and just a count at this point, but there's nothing keeping me from actually putting that information into another browser somewhere or something like that. The connection IDs that it passes around, I believe it's just a GUID. It's just a string. It's a hash that, it's either a hash or a GUID that doesn't have a lot of significant value to it. It's just a pointer to that specific connection. Now, I also added this block here as of, because I want to show you a little bit of being able to call the methods inside that hub from outside SignalR. At this point, we've just called it from a client. We've called it from our browsers and thrown messages back into the server and sent those messages back out to other browsers. But what if I have another method? What if I have a hosted service that's sitting somewhere else inside of my application that is going to send messages here that are going to interact with it? Not quite service worker, but hosted service. So I built a hosted service called timer service. And this is the dumbest, simplest service that you could build. And all this is, we'll talk about hosted services in an upcoming stream, but this is going to run in the background. When it starts, it sets up an execution thread and calls this execute method. Execute is down here, and while its cancellation token is not canceled, it's going to send a message to all the clients and say, call the timer method and pass into it the minutes in seconds. Well, how's it getting the context of that? And this is dependency injection. We learned about dependency injection about a month or two ago. You can find it earlier in the YouTube playlist. So here we're receiving in our constructor this iHub context. This is a pointer to the context of the SignalR hub called ShapeHub. So I'm going to go find get me connected so I know how to interact with that context. I stash an instance of it inside this private read-only field so that down here I can say clients all send timer and send here's what the current time is. Wait 1 second and send the timer again. Back in my webpage, I'll make this last demo available. So when we receive a call for timer, execute the timer method, I'm going to go into the timer element, which is this span right here, and I'm going to reset its text to whatever was sent to me from the server. Let me restart the server so I can get that latest content. There you go. You see it's not connected. And I'll refresh so the JavaScript is in there. There we go. And now they're all ticking at the same time. They're all receiving these messages and painting and updating the browser once a second. And it's continuing, right? It's running here locally. Just my machine. There's 6 of these that are connected out here. And this still works. It's showing me 6 connections because I've got 2 other tabs here. And we've got this rich interaction. Sorry. We've got this rich interaction that's painting and showing information as it happens on the server. Now I'm just passing time. That sounds weird. I'm just passing time information down. But maybe Think about all the cool live things that you might be doing. Maybe you're trading stonks. Stonks? Sure. Maybe you're long on GameStop, and you want to have that information pushed to you as it changes, right? So that you have a live update from that stock ticker. Great example of just repaint that element of the screen. Do whatever kinds of user interface interactions you want to make that appear. I already mentioned over on my channel, folks execute commands inside the chat room, and there's a socket that's listening on a hosted service, just like my timer service that we saw here, that is listening to Twitch, and when it sees one of those chat messages it's interested in, it sends a message across to a hub context that plays a sound effect or puts something fun on screen. Okay, now we're talking, right? All kinds of ways that you can interact with this and push and pull data back and forth with almost real-time interactions. We really like this. We think this is fantastic. All right? So, what about getting into another another client? Maybe I want to do this move shape gizmo here with Windows Forms, right? I want to put something out there that's going to be able to connect to this server, and it's an application. And I want to see the number of connections that are out there. I want to be able to do that interaction. So, right, or maybe it's a mobile app that's running on Xamarin. Let's take a look at using that. Let's take a look at using that SignalR client with a Windows Forms application. Bakir is saying 10 concurrent session limit on IIS. I don't know why. It shouldn't be showing that, because you can push through a lot more connections than that. Site, Docs, Microsoft, Com, SignalR Core, IIS, connection limit. Shouldn't show 10. WebSocket connection. It recommends sticky sessions, TCP connection resources. This is, yeah. IIS limitations. Windows 10 and 8X are client operating systems. IIS on client operating systems. So when you're running on Windows 10 or Windows 8, yes. 10 connections running on a client operating system. Makes sense. When you're running on a server, that effect isn't in play. So you will likely hit the 10 connection limit on a client OS. When a client OS is used for development, we recommend avoid IIS, use Kestrel or IIS Express. Yes. Nginx, you can tune all kinds of different ways to enable WebSockets, servers and events, long polling. Yep, use sticky sessions, so you're always connecting to the same server, so you're always getting the same information being sent back and forth. So, yeah. So, working on the client, yeah. Yeah, when you get onto a Windows server, you won't see that limit. But working here locally, no problem. Piece of cake. All right, so I was going to get into Windows Forms. Horizontal scaling is no problem with SignalR. That's correct. Yep. So there was, let me go back over to that browser. There's a discussion here about hosting and scaling. They talk about SignalR backplane providers. Encache, Orleans are available. There's a Redis backplane. There it is. That you can use that connects to Redis and sends information back and forth. And there's also Azure SignalR service. So I will share that part of the link. So sure, you can use it in Docker containers as well. So that running the server on a client OPSYS, not running the client operating system. Yeah, Windows client operating system. Our client operating systems. IIS on client operating system has a limit of 10 concurrent connections. That's an IIS thing. So, yeah. So you should be able to use SignalR very well with Kubernetes. So, not avoid IIS. IIS on a client operating system. I mean, come on. If you're running a production web server on Windows 10, you've got other problems. That's not 10 concurrent connections for SignalR. That's 10 concurrent connections, period. Requesting web pages, streaming data to them over IIS. So, if you need to serve more than 10 folks, don't use IIS on a client operating system. Use a server operating system. Use a cloud hosting provider that has this all set up and configured for you. So, all right. Let's take this client and let's do a Windows Forms client application real quick here and show you just how easy this is to get wired in and work with. So I'm going to add a new project here, and I'm going to choose when it loads up. Windows Forms. Come on. You're gonna go. Thank you. Windows Forms app. This is Windows Forms on. Sure, that's a fine name. This is Windows Forms on .NET 5. So this is our latest version of Windows Forms that's built so that it will handle high DPI displays. It's been optimized with all the things that were in .NET Core, and we've migrated to .NET 5 so that it runs very high performance. So I want to do the same move shape interaction here that I had in the other one. So I'm just going to grab a panel object and drag this over here. And let me grab the properties and let's make it just like the other one was. Where is the size? Size. There we go. Oh, I was close. Look at that. I want to make it 100 by 100, just like the other one is. Okay. Let me make the background color. Let's make that. Scroll down here somewhere. No, I want the web colors. Thank you. And I'd like blue, please. There we go. So I want to do the exact same thing, right? You know what? I can also add. Where's the toolbox? Over here. Give me a status bar. Here we go, status strip. Thank you. Let's update this. Let's edit items. Thank you. It's over here. Let's add a status label. This one, I'll call this LBL connections. Thank you. I'll add one more, and I'll call this LBL timestamp. Cool. That's easy. And I'll just, oh, I need to add the NuGet package. So, browse, pull down this chalupa, Microsoft ASP.NET Core SignalR client. It's like I've done this before. So, yep, go ahead and install those things. Thank you. Close this. And I'm going to jump to the code behind on this form. And I'm going to set up a connection. So let's define a connection equals, so I want to do a, what is it? A connection, what was it? The SignalR connection builder. It was the same. It's the same syntax over here that we have over here. SignalR hub connection builder. That's what I'm looking for. And I'll control dot, get the IntelliSense for my using statement. Thank you so much. With URL, my URL is going to be not L, localhost 5001 hub, and what was the name of it was setup is what I'm looking for. No, startup. That's what I'm thinking of, and it's the configure map hub. There we go. /hub/shape. I don't need that. You go away. All right, so that's where we're connecting. Sure, let's get with automatic reconnect. It does the exact same thing. It's the exact same syntax, except it's very C# friendly syntax. I have a retry policy I can pass in there, a time span array for how often you want it to connect. And I'm just going to say build. I'm not even going to configure logging with this. So now this connection, yep, generate that field. Don't mind if I do. Just like I did before, connection on. And I'm going to be receiving 2 integers for the move shape method. Excuse me, called client move shape. So I have generic here for the 2. I'm going to specify the name that I'm listening for, and now I have an action that I can execute based on those 2 integers. So I'm going to receive that as X and Y coordinates, right? And what is it? Just called panel 1? Yeah, there we go. Panel 1 dot top equals well, it's the Y coordinate, right? And panel 1 dot left equals the X coordinate. Got that. All right. Connection on. I'm going to receive this time an integer for the count, right? It was just called count. And that is going to go on LBL connections. Text equals, do a little string interpolation. Connection count. Okay. And come on now. Come on, Fritz. What are you doing to me here? There we go. Last one. We're going to receive a string because that time that was sent was just a string, right? It was just called time. Was that the name of my method? Timer. Same thing, right? And I love how the syntax is basically the same in all of these technologies. And I'm just gonna output that as the time right there, and like this. And my application, my server is still running in the background. That's not the right one to start. No. I want to start because I have it running on the command line over here in a terminal. Start my Windows Forms app. Hey, how's it going there, Copper Beardy? Ordinary Boy asks, do I upload all streams to YouTube? Yes, I do. You betcha. So there's my Windows Forms application, right? And let's just kind of tuck this somewhere here in the rats. Let's kind of tuck this somewhere here in the middle, something like this. And why isn't it moving on my Windows Forms app? I told you, every time I do live coding, I make the same mistake. And as soon as I started this, I knew, oh, look what I forgot. You have to start the connection. I forgot the connection. I forgot to start it. So, let me restart that. I'll see, right, I've got the fancy zones here, so I need to kind of drag this in so I can make this appear. All right. And you can see connection count 7, and it's getting the time, and right, it's now dragging. Right, it's now moving the shape for me. Right? Cool. So now I'm connecting and I've got this rich interaction that's happening live across now multiple clients, multiple technologies. I don't need to think about how this works. I can have the exact same syntax. I can respond and listen the exact same way across JavaScript. The JavaScript client is actually written with TypeScript, so you can use TypeScript as well. .NET, so whether it's a .NET standard client, so you can use it on .NET Framework, Xamarin, .NET 5, .NET Core 3.1 and earlier. You can use it on Blazor. Really great stuff that allows you to interact and send this information back and forth. Ordinary Boy has a question. It's a little bit off topic, but I don't mind taking it. Does the Apple M1 concern the .NET team? Will it affect the speed of the development process? No concern. We've been developing and building towards ARM64. Our technology with .NET Core, with .NET 5 supports ARM64. It should compile and run there, no problem. So they're already targeting a series of different runtimes, a series of different chips and operating systems. No concern. .NET 5 does support ARM64 natively. So .NET running natively on a Raspberry Pi. Yes, indeed. Yep. And that's also ARM architecture. So no problems there. So I've gone through a bunch of different demos here. This with the move shape and showing passing data around, whether it's connection counts or times, right? We can see this coming around, streaming this data. Streaming's the wrong word, but the latency in passing things around. And that's what I think is so compelling about the move shape demo is it so quickly appears. The chat room is a typical demo you'll see people do when they show off SignalR, because it's something that folks understand, but you're sitting in a chat room as part of this. Big deal. You know what a chat room is. You know how the chat room works. But showing something as simple as a shape moving in the low latency here, I think is a little bit more interesting. And of course, your ability to connect through and tinker with, where'd it go? Tinker with images here live on screen, routing through Azure, wherever you are, sending it out to an Azure server that happens to be in East US, and delivering it back to me here on screen. I think that's pretty cool as well. That's pretty easy for folks to get their arms around and understand. Oh yeah, this makes sense. I can see how this is interesting and compelling. Now, somebody was saying, I could put the connection. Somebody was saying, gosh, you should track how many times the buttons have been clicked. I should put the number of, I could put the number of connections and the number of clicks in the browser. I have a few minutes left here. I have about 15 minutes left. Is that something you want to see me do real quick? What do you think, chat room? And of course, all of this source code is on GitHub, and I'll be updating these appropriately. Ordinary Boy asks, does SignalR provide good performance? For example, can it be used for instant messaging? Do you see how fast well, there's a video delay coming through on Twitch and Learn TV. The latency of these things, I think is kind of compelling here. Even if it took a second for those squares to keep up, right? Because it's sending the message to a server and relaying it. Yeah, I think would be quite good for instant messaging inside of a web application. Oh, yes. So I do see folks saying, yeah, why don't we add that real quick? Why don't we add the number of connections into the application that I've deployed there for the emotes. So I'm going to do almost the exact same thing that we have. I'm actually going to steal the code from Shape Hub and put it in the Emote Hub. So I'm just going to grab these, and now I'll do the thread safe. Now I'll do the thread safe interaction for this, and I'm actually not going to do that, but I'll add this up in here. I'll make this async, so it does that, and I'll also want to do get this count. So private static int count. Let's start it equal to 0. Now I'll do threading I'll do an interlocked increment and decrement. So when you have to do this type of working with a variable, you use this interlocked, system threading interlocked method, so that you're ensured that you always are working, the only one working with that number, that variable. So I'm going to pass in the count, and this will increment that. It gets a reference to it, increments it, and returns appropriately. So I'm going to do the same thing down here. I'm actually just going to copy and paste because it's a little bit faster than me typing. And instead of increment, I'll change that to decrement. Does the exact same thing, just minus minus on it, but it's doing it thread safe. That's what the interlocked does, is it makes sure that it's the only one that's making that change and act appropriately. And when this could be, because this is a static here, and we might have multiple folks hitting it at the same time, it could be a little crazy. Now, the other one folks were saying was, hey, can you track the number of times that the emotes have been clicked? Sure. So let's do that. Let's make this a long emote clicks. I'll start that at 0, and I'm going to do the exact same thing down here on send emote. Let's get rid of this log statement. Don't need that. And I'll say interlocked increment emote clicks to make sure that that runs properly. That was easy. So I'll be able to see that information. Now I want to show that to you on screen. So I'll go back over here, and beneath the buttons, let's do this. H2, some, really? Some stats. There we go. So let's do a data list. Definition term, connections, and the definition I'll have in here. I'll just call this count to make it easy. Next one, emote clicks, right? And I'll call this clicks, so it's easy for me to find. Let me grab the exact same code that I have over there in move shape for the connection count, because it's the same method, right? So here, right? Connection on, when I receive count, I'm going to go into, let me set up constants for those so I'm not doing a document get by ID each time that those are clicked. So document get element by ID, and I'm going to go get the count element. Clicks, same deal. Oh, come on. Thank you. Get element by ID clicks. So I have those two available. So count text content. I'm going to do the exact same thing. What was the name of the method from the emote hub? Not only do I want to send that out, but I need to also send this out to all the clients. And I should do that second. Probably shouldn't await it, but I think that's all right. Clients.all, and let's call this clicks, and we're going to send out that number of clicks. Send async. Don't forget that part. All right, so we're going to send clicks, and this is going to clicks text content. Let me rebuild. Doing await task.wait all. I could do that. Could do that. So, how would you use the interlocked when the Azure App Service is scaled out to multiple instances? Put it in a database. Put it somewhere out of process. Oh. It's running in the background. It's not going to let me build while it's running on my terminal. Yeah, could not copy because it was running out here. Come on. I stopped the server. Come on. Yeah, I know. I know. Should be clear. There it is. Build succeeded. Cool. Let's deploy. So I'm going to right-click, publish. I've already got it set up to publish. There it is. And there's the subscription ID on screen. So it's going to build, it's going to deploy. There it goes. Well, actually, right-click deploy will now generate a GitHub action for you. So now if we go over to the emote demo, go ahead and refresh that screen, and you'll see the number of emote clicks coming through. I think I need to refresh over here. There we go. I don't have on the OBS page, I don't have with automatic reconnect set up. Over here. Right. I didn't have that in. No matter. But you can see the number of emote clicks going up. 20 folks connected, clicking buttons. So, works well. There's a question here from Mr. Smoofy. We'll let the emotes fly on the screen here for a bit, and let me go over to Mr. Smoofy's question, which is, where'd it go? Where did that browser go? It's that one. And I need to give you back this one. There we go. So where did it go? Mr. Smoofy's question. So Mr. Smoofy asks, looking for a way in .NET Core Worker service that is running as a Windows service to get the physical directory location of where the exe is at every time. I've tried to use something like use reflection. Whatever object you're in, startup.getType, get executing, and assembly, get executing assembly, and you can walk down and you'll see where it executed from. What level app service am I using? This is the free instance. How many SignalR connections do I think it could roughly handle? Well, it's handling 31 right now with no problem. So, 32 connections, and the number of clicks coming through is 1,800. So, not too big a deal. Yeah, thank you, Rambling Geek, for typing that out. Look at that. I called that out of memory, and I got it just about right. Thindoll has a question here. How would you do app-to-app connections with WebSockets? Why WebSockets? WebSockets, you're clearly connecting out to a server. If you're doing connections between servers, you don't want to use WebSockets. You probably want to use just sockets. So you're doing server device. Okay, if you're doing server device, then I wouldn't use WebSockets if you don't have to, because some of these conveniences that we have in SignalR, I think, are worth it. automatic reconnect, automatic negotiation of the protocols, being able to step down, step up, force the reconnect to happen appropriately when you're ready for it. So these are advantages of using SignalR. If you did have to use sockets, you're going to look at using TCP client to interact. There is a WebSocket package inside of NuGet that you can get that will help you build a client. I've used, see these folks building WebSocket clients, .NET, SystemNet WebSockets. Works great for interacting with it appropriately. You can see runs on .NET Standard 1.3, which means it'll work on all the mobile platforms as well, and .NET Cores, .NET 5 as well. So, not bad. These are technologies you can use to help with that communication. Sockets are a very powerful way for you to interact, very powerful interface, and I'm pretty happy with how this has worked. So, it's not just a wrapper for WebSockets, Caparino. It also has, that's its primary thing, is it's a wrapper for it, but it's also got the ability to step down if for some reason WebSockets are blocked on the network. If you can't get there, it has other ways to do it, and that abstraction provides so much additional value on top of WebSockets. The idea is to connect a device to an ASP.NET Core application, send data both ways, and have automatic reconnect. Take a look at SignalR. SignalR is going to abstract and take care of a lot of that for you. All right, we are just about out of time. Let's wrap this up. Let's stop the music and head over to. Hello, I hit stop. I'm pressing my Spotify pause button and it's not pausing. You make me sad. Let's head back over to the main screen and let's call this a day here. My gosh, that was a lot of fun. Thank you so much for participating in our little interactive demo there with the emotes that you were able to throw on screen. Really cool stuff. All of the samples are available over on the GitHub repository. I've got an initial version out there in a session 0206 branch. That'll be merged into main when we publish the recording of this over on the YouTube channel. A little bit later today, probably in the next day or two, you'll see it pop up over there. Thank you so much for tuning in. I hope you come back next week. Next week we're going to be talking about security. How do we work on authentication and authorization of our applications? This is the one that I'm afraid of. This is the session that I always have problems with, and I know I'm going to have a Barry Dorans keeping an eye on me for next week. Thank you so much. Those of you that are watching over on Learn TV, I hope you have a great day. And those of you that are watching on the YouTube broadcast, make sure you check out the rest of the series. I've got links to the rest of the playlist here and links to the previous video right here that you can click through. Now, have a great one, and I'll see you next time.